Hey, you want to hear a funny joke?
Yes.
Okay, I haven't even said it yet, but
Yeah, go ahead.
yeah, it's going to be really funny when I actually say the joke.
Okay.
So, why did the picture go to prison?
To get away from the mirror.
No, because it was framed.
Oh. That's a good one. That's a good one. Yeah.
Yeah.
Yeah. Do you have any more? I've got one more for you.
Okay, go ahead.
Okay. What do you call a fake noodle?
A fake noodle? I don't
Or
know.
in pasta?
Okay, nice, nice.
Hello and welcome back to Yeyu Lab. The conversation you heard just now is from a demo that a human user speaking to NVIDIA's new model called PersonaPlex, which is an open source 7B model that can listen and speak at the same time. It interrupts you, back channels with and haha, and responds in true real time without any notable latency. And NVIDIA gives the original model with a rich persona libraries. That means you can select your own text prompt and many voices from it. Today, I'm gonna deploy it on a cheap cloud GPU and try to talk with it. So every voice AI you've used has the same problem. You talk and wait, it responds, but there's always a gap that's awkward silence while the system transcribes your speech and send it to an LLM and generate the text and then synthesize audio. It feels like talking to a machine because it is a machine. Three machines chained together, actually the ASR, LLM, and TTS. The three models will generate three delay that accumulate the overall latency. PersonaPlex comes from NVIDIA's ADLR, Applied Deep Learning Research Lab. The core idea is that the traditional conversational AI forces a trade-off. The cascade systems from ASR to LLM to TTS give you the voice and role customization, but the conversations feels robotic for sure. And full duplex models like Mosh made the conversations feel natural but lock you into a fixed voice and role. So PersonaPlex breaks that trade-off. You get the both for the full duplex capability with a free customizations of voice and roles, like assistant, like banking customer service, like a medical office receptions, like space emergency scenario. So for the technical implementation of this model, you can go to its GitHub repository to see this model architecture. To find it's based on Moshi architecture and weights, which is a 7 billion parameters model, and a mini natural speech decoder converts the audio to tokens, and temporal and depth transformers process the conversation. And a mini speech decoder generates the output speech in real time. The key is that it operates in dual stream model. Listening and speaking happen concurrently. The audio runs on 24 kHz, and the underlying language model is the Helium, which is what gives you the generation ability beyond its training data. Now let's get this running. To run this 7B model in full quantization, you have to have a decent GPU to handle it. I'm using RunPod platform because it gives you a cloud GPU port with SSH access in about 30 seconds for setup. It's a better approach when you need to have a temporary test. And for this model, NVIDIA officially demo it's using A100 or H100, which is too much expensive for our test. But for my test, a 4090 is much enough for it. Let me show you how to create a port in RunPod platform if this is the first time you do it. So in your console, you find this port here. This is the pool of all the available or unavailable GPUs that you can select. And for the instance option, I recommend to use the secure cloud because it is handled by the RunPod officially, and community cloud, including the GPUs that provide much cheaper but with unstable connection and performance. And you can select the network volume or any region that you want to maximize your network speed. So in this list, we can choose this one, RTX 4090 with 24 gigabytes VRAM, and it is only $50 for 1 hour. That is very cost effective for our test. So let's click it, and now we can choose the port template. PyTorch 2.4 is quite enough, and we leave the GPU as 1 and choose the default pricing model, enable the SSH access and Jupyter Notebook, and use the volume desk. If the network volume is not available, just click deploy. It should have give you some gift credits for your first login, or you can top up with a little dollars to the account. And now after provision, port is fully online, and now we need to do the next 2 steps. You can tunnel the port to your local machine by using the SSH connection string, or you just use the HTTP services by directly access your port on the browser with Jupyter Lab. Now I can click the Jupyter Lab link to open the Jupyter Lab environment, directly access the port. This is the environment. You can use the notebook or use the console. Here I just simply use the terminal, and this is our port. It's just a normal Ubuntu environment. So for our test, next step, we should install all the necessary libraries to run in this. This is the list of libraries that we need to install. Okay. You should export your Hugging Face token that allows you to run this model. So what I mean is you should find the model in Hugging Face, and here you see it's gated model. You have been granted access to with this model before, so that I can find my access token in my account settings, or I can create another new one specifically used in this test. So once you have a token, just copy that token back into our terminal of the port, and adding another parameters Hugging Face hub, enable Hugging Face transfer to be set. Now everything's ready. We can just simply run the moshi.server using the script Python moshi.server at the open host, the default port 8998. So inside the server running process, it will download the models and run the model internally. Now you see that you can access the web UI directly at HTTP port 8998. But the key is that without the HTTPS setup, the HTTP connection will be blocked if you use the voice interaction. So we have to forward this port from the RunPod environment to our local environment to pretend to run this service locally, that our browser will give the access for the voice usage. So what we do right now is to use a SSH command to create this tunnel from the remote TCP connection to our local host. You should make sure that here the IP address should be the same, the port should be the same that's dispatched by RunPod at beginning. You should have key pairs and register the public key in the RunPod system. Once you run that, for the first time, it will ask you to confirm the key fingerprint. Let's type yes. And then once access is established, you can access the web service on a port that we deployed on your local browser. Now you see that the local hosts 89 and 98 is fully working. It's a very simple web UI that gives you the choices to select the example text prompt to define the roles of the voice assistant, or you can use the default roles and adding the prompt by yourself. And also there is a big list of the voices that you can select. And if you don't know how to create the public key for your SSH connection, you can quickly go to the settings here, and in the settings you will find there is SSH public keys, and click that. Here you can provide your SSH public keys. You can find many quick tutorials on the internet to tell you how to create the pairs of public key and private key in your local machine, and how to retrieve the public keys and paste here. Okay, let's try to do the first example that I'm thinking of. Let the model to be a restaurant service. So here is my prompt. You work for a Chinese restaurant and your name is Kevin. Here is the information of two main dishes that provide to your customer. One is Kung Pao kitchen, the other is beef with broccoli. Both comes with a choice of white and fried rice. Side dishes including pork eggs rolls and crab rangoon. No substitutions on sides. Takeout and delivery only until 10 p.m. So I will choose some natural voice F3. I don't know its voice, but so let's hear.
Hello, welcome to Golden Walk. This is Kevin. How can I help you today?
I want to take out my food.
Great. We have two main dishes. Kung Pao chicken that's spicy with peanuts, $12.50. Beef with broccoli mild, $13.50. And you can choose white or fried rice with either.
Hold on. You mean Kung Pao kitchen has peanuts or not?
Yes, it does. Spicy with peanuts.
So can we remove it because my friend is allergic with peanuts?
I'm sorry, no substitutions on sides. That's the only option for Kung Pao.
So I think I need the beef with broccoli.
Sure. Would you like fried rice with that?
Do you have anything else?
Yes, pork egg rolls are $2 each, and crab rangoon is $4.50.
Okay, please give me.
One beef with broccoli, fried rice, and pork egg rolls. That's $23.50 total.
Thank you so much.
You're welcome. Would you like delivery or pickup?
I want delivery. I want
Great.
pickup.
What's your
Sorry,
address?
I want pickup.
No problem. What's your address?
No, I want to pick up, so I will take out by myself.
Got it. When will you be ready?
So the second example will be accident handling. So here for the prompt, I said you are a bug bash, a highly competent but slightly cynical senior DevOps engineer. We are currently pairing on a live server outage. A Kubernetes cluster is crashed looping. You speak in short, directly technical sentences. You don't use polite filter words. You get straight to the point. So this is normally something that we're handling every day if you are working with some IT guys. Let's see how it works. Oh, let's choose the maybe a male, natural male 1 voice. Let's connect.
Hey, let me know if you have any questions.
I think the production pods are crashed looping again.
Yeah, I see that the pods are crashing looping. We probably hit a Kubernetes scheduler bug. Have you checked the pod health logs?
I haven't. I'm looking at right now, but I didn't see any memory spikes.
Okay. You might want to clear
let
the
me
pods
check the
and
deployment YAML.
Alright, take your time. We'll wait. Just let me know when you're ready with
Oh
the
wait,
logs.
oh crap, the resource limits.
Oh no, the limits are hit. What's the number?
It's 512 megabytes. I think it should be 512 gigabytes, right?
Right, 512 should be higher. Let's bump that up. Anything else in the logs?
I'm applying the new settings. Should I bounce the ingress controller too?
Yeah, you probably want to reset the ingress controller. Just make sure the settings match. Once that's saved, the new settings should kick in.
Okay, I got it. Thank you.
You're welcome. I'll stay on the line. Let me know if anything else pops up.
Okay, in the final demo, let's quickly check out its own default prompt to have some fun. Here, there is an astronaut. Enjoy, have a good conversation, have a technical discussion about fixing something on the spaceship. And you already deal with a React core meltdown. Oh, it seems very urgent. You explain what is happening. You urgent ask for help. So it's like an urgent support need to be happen. So let's try some different voice variety F1 to see how the model reacted.
Hello, this is Alex. I'm on a spaceship. We have a problem. We're having a core meltdown.
Yeah, Alex, skip the telemetry. Did you vent the primary coolant loop?
We've got several systems failing. We need help fast. The core is unstable.
Use the manual override handle on panel 4.
Panel 4, manual override. Got it. Any other details?
But anyway, the reaction of this model in voice is super natural. You can hear from the demos. I think it's the most natural and quickest response throughout all the AI voice assistants. The only defect maybe is the LLM model itself is too small, only 7 billion model. So definitely it cannot handle very complex context generation internally. So we were researching this model more deeply to find out how to connect this model to outside tools, MCPs, or other way to improve its output quality. But the speed and the reflection is so impressive. That's all for today. If you have further ideas or questions, please drop them in the comments below. Thanks for watching. I will see you in the next video.